Okay, some of us remember. First of all, when it's even, they are going to each either both go up or both go down. Think of the graph of x squared, parabola, right? I know that's our most basic even function. Doesn't it either open up or open down? We discovered that a few weeks ago, that when we have even powered functions, there might be some dips and maxes and mins in the graph, but they're both going to point up or down. So because this is degree 4 and the leading coefficient is positive, I'm going to just draw this here. The ends of the function are going to both point up. So that's how we tell what the end behavior is without looking at the graph. Does anyone remember, think about how we did it with a parabola or an x squared graph. This is called standard form, not factored form. Does anyone remember where I can find the y-intercept of that graph? If you think you maybe remember, can you turn and talk to the person next to you about maybe make a guess as to what you think the y-intercept would be? All right, I did hear a couple people talking and I heard -30, okay? So in standard form, so far we know 2 things about the graph and I haven't even looked at it, okay? The end behavior we're gonna get from right here, and we know that this constant term is the y-intercept, okay? So let's jot that down, at least for our graph part. The y-intercept is going to go through the point 0, -30. Okay. Now, when it's in standard form, those are really the 2 things that we know. So in standard form, the polynomial will give us the end behavior. Remember, we're going to get that from right here. And I'm going to graph it in a second. So the end behavior is up, up, and I get that from the degree and the leading coefficient, and then we would know the y-intercept. Okay, now let's look at the factored form. So notice I factored it for us. You see that? So this is now this in factored form. Are we good with that? Same graphs? It's just different forms. What are these going to tell us? Good, the x-intercepts. Let's list them. Remember what we discovered. Just like with parabolas, x is a liar or they're opposites. So if this factor is x plus 1, one of the x-intercepts would be -1, 0. All right, if we now have this x minus 2, we have also an x-intercept of 2, 0. Very good. Let's keep going. X plus 3 would be -3, 0. And then x plus 5 would be -5, 0. Okay, so let's put this all together now. So what we're going to do, or how I kind of attack this problem, is I do not care about, there's going to be turning points. We don't know where they are, and that is fine. What I care about is, are your ends right? We can do our y-intercept and our x-intercepts, okay? So on our graph, how I start this is I'm going to just put dots on the x-intercepts. So it looks like the largest one is -5, so I'm going to just do a tick mark of up to 5 on both sides. Okay. And then for my y-axis, I do need to go down to -30, right? So I'm going to just go, now here's the deal, it's a sketch. If you want to just put a little slash mark and make it a -30, that's fine. I'm going to just do this I'm going to make this negative 10, negative 20, and negative 30. Okay, so now I'm going to put some dots on my graph of points I know it goes through. Would you put a point at negative 1, 0, please? And then we're going to put one at 2, 0. And then we're going to put one at negative 3, 0. And negative 5, 0. Okay. Now, one thing we talked about yesterday is all of these x-intercepts, the graph is going to cross through them, right? We'll talk about that difference in a second. Let's also put our y-intercept on here. So when we're going to draw our graph, we do know it goes through that point. That's the only thing we know. Okay, let's put it together. If I want to have my end behaviors be up, okay, because they're going to go like this, up and up at the end, I am going to start the furthest I can from the graph. And I'm going to go down, and then I do not know how far it goes. Yeah, question. Is it? 1, 2, 3, 4, 5. Oh, this one. Thanks, Mason. Jolly Rancher for you. Okay. Yeah, I put it at negative 4, 0. It should be negative 3, 0. Thank you. So I'm going to start by going down. Do I know how far it goes? Nope. At some point, we're going to make it now turn around, and we're going to have it go up. Do I know how high? Nope. We're going to now, at some point, because it's got to cross again, we're going to make it turn down. All right, now, this is the only one where I have to at least make it cross at negative 30, so I'm going to make it pretty steep. And now it's going to go up again through 2, 0. And that's it, right? There's no other x-intercepts. So we're going to continue our graph and make it go up. Remember, because our end behaviors had to go up. That's what we're going to practice today. Okay. So I guess my question is, let's talk about our topics. If it's in factored form, do you know how to do the x-intercepts, or do you want me to talk about that again? If I give you this form. Okay, if it's in standard form, do you know how to cut the y-intercept, or do you want me to talk about that again? How about the end behavior? Okay. So the end behavior we're going to get from the degree and leading coefficient. This will be kind of our summary today. The y-intercept, we get from we call that the constant term. And the constant term, what's significant about the constant term? What does it not have in it that the other things have? What did negative 30 not have behind it that the other things have? A variable. Okay, so if that helps you, the constant term is the term with no variable behind it. And the x-intercepts, we're going to get from the factors. But were they the same number as the factors? No, they were the opposites. So I would write that down. How are we feeling about this? I can't tell. You guys are so quiet. You can give me a thumbs down if you're not feeling good about it. Okay, part 2. I don't know if remembered this from yesterday. This was the point, but some of you blew through the activity. You should have at least gotten to this part. We started putting squareds yesterday in our factors. Who remembers that? Okay, good. So you started to see there was a squared, and I was trying, some of us didn't understand, well, what it did. They saw that it was like, okay, it does something. When we start putting, these are called multiplicities. Here's why. Do you see here x plus 1, x minus 2, just two factors? Those are called linear factors because they have degree 1. Then I started doing things like this. By the way, it looks like it's far away, but that squared is by that x minus 2. So what this really means, guys, is this is x plus 1. And how many x minus 2's do I have? 2 of them. That's what that really means. But we're going to see it written like this. So we call this a double root. Does that make sense? Because there's 2 zeros technically at -2, but there's not 2 separate points on the graph. Does anyone remember what it did? So I don't have to switch screens. I'm going to pull this up on it. Okay. It was x minus 2, and then we squared it. Okay. Okay. Do you see this right here? This is the 2, right? Does it, do you remember how on my last graph they crossed through? We went up and we went through the x-axis. When we have something like a double root, it touches, and I say it bounces off. Does that make sense? Do you see how it touches at 2, but then it doesn't cross, it just bounces up again? Okay, so when we're graphing things like that, we're going to, first of all, there's 3 factors. So what is the, if there's 3 factors, what's the degree of this polynomial? Degree 3. I know it's not written in standard form, but we can still tell that. I'm not going to make you multiply them all out to tell me that, but couldn't we multiply this times this and then multiply through by the x minus 2 and we get an x cubed? That's what I'm saying. So x times x times x, that's where I'm getting the x cubed from. Do you see how in front there's nothing? So it's got a leading coefficient of 1. Okay, when that happens, the end behaviors go opposite ways, okay? So I'm going to do for my end behavior, it's going to go down, and then it's going to end up. So it looks like that at the end. And then if we have a squared, that's something that bounces. So for this one, I'm going to put my -1 on there. And I'm going to put my 2 on there. Remember, this is a double root, so this one's going to just bounce off. I put my points at -1 and 2. And then I start with my end behavior. This function starts down. Comes up, I don't know how much. It comes down, but instead of crossing at 2, it bounces off and goes up again.